Good morning. This is Team Neo, and we are going to present a presentation on Chatbot that we have built using BERT and Tensorflow. Our team members are Anshu, Shreyas, Niril, and Evan. Next slide, please. So let us discuss about the project overview. So here, we create a functional chatbot using BERT and TensorFlow. The primary goal of a project is to develop a chatbot that leverages the power of BERT and TensorFlow. BERT is basically a transformer-based model that is designed to understand the context of words in a sentence, making it highly effective for natural language processing tasks. TensorFlow is an open-source machine learning framework that provides comprehensive ecosystem for developing and deploying machine learning models. Now let us understand the steps that we have used. First is data collection. Gathering data from various sources is the first step. The data will be used to train the chatbot to understand and respond to user queries effectively. Second is processing. Before feeding the data to the model, it needs to be cleaned and formatted correctly. This involves filtering out irrelevant information, normalizing text, and ensuring that the data is suitable format for training. Third is model training and evaluation. Using the pre-processed data, the model is trained to understand and generate responses. This step involves splitting the data into training and validation sets, choosing appropriate model architecture. The model's performance is evaluated using various metrics to ensure it meets the desired accuracy and efficiency. The last step is the deployment. Once the model is trained and evaluated, it is deployed to the production environment where it can interact with the users. This involves integrating the models with a user interface, setting up servers, and ensuring scalability and reliability. Now, let us discuss about the problem statement. First is the limited understanding in existing chatbots. Many chatbots struggle to comprehend user inputs, especially when the context is complex or the language is nuanced. Second is difficulty in maintaining the context. Traditional chatbots often fail to remember the context of a conversation, leading to the disjointed and unsatisfactory user experience. So let us discuss about the goal of a project. We aim to develop an intelligent chatbot with context awareness. This aim is to create a chatbot that can understand and retain the context of conversations, provided with more relevant and coherent responses. Second is to improve user interaction experience. By enhancing the chatbot's understanding and context awareness, the goal is to create more natural and engaging interaction experience for users. So next slide, please. Yeah, so Anshu will discuss about the methodology, please.
Okay, so let me explain data collection and pre-processing. Starting with data collection, our primary sources were Chatbot data and a custom intents.json file. So we used the first intents.json file and expanded it over time, but it wasn't enough. So we decided to use Chatbot data to train the AI better. The data type we worked with was text consisting of conversational patterns and responses. This textual data forms the backbone of our chatbot's ability to understand and generate human-like responses. We then updated our data set with the filtered labels while maintaining a clean and well-labeled data set. We could enhance the accuracy and robustness of our model. The final step is our methodology for data splitting. We split our data into training and validation sets, typically in 90-10 ratio. The division is essentially for evaluating the model's performance. And by following this structure step, we ensured that our data was not only comprehensive but also clean and well prepared. Next slide, please. Now I will explain word embedding. So, the primary purpose of word embedding is to capture semantic relationship between words. This means that words with similar meanings are positioned positioned close to each other in a embedding space. For instance, words like king and queen or man and woman will have vectors that reflect semantic similarities. And for example, consider the famous example in the word embedding space king, man, woman, queen. This example demonstrates how word embeddings captures complex relationships between words. By subtracting the vector of man from king and adding the vector for woman, we get a vector that is very close to queen. This ability to perform arithmetic operation on word vectors is a powerful feature of word embedding. So next slide, please. Now I will explain creating word embeddings. So first we import the necessary libraries for our project, like GenSim work to vec model. So we used GenSim because it's a robust library widely used for neural language processing tasks. GenSim provides a efficient implementation of various algorithms for creating and using word embeddings. Then, then we defined our word-to-vec model. The word-to-vec algorithm developed by Google is one of the most popular methods for creating word embeddings. We configure our model by specifying parameters such as vector size, which determines the dimensionality of the word vectors. Typically, a vector size of 100 to 300 dimension is used, depending on the complexity of the dataset. The window size parameter defines the context window, or how many words to consider to the left and right target word during the training. Uh, a window size of 5 is commonly used, capturing enough context to understand the word's meaning. So after defining the model, uh, we train it on our sentences, we provide the training data and set up the total number of examples and epochs. The model iterates through the data multiple times, adjusting the word vectors to better capture semantic relationships. This training process results in high quality word embeddings that our model can use to understand and generate text effectively.
So moving with word embeddings and the training word embeddings. So in this slide, like we focus on how we train our word embeddings. The first step involved is like filtering the labels to ensure all values were within a valid range, which is crucial for maintaining the quality for our data. After filtering, we updated our dataset with these filtered labels. Finally, we split the dataset into training and validation sets. This preparation was essential for creating uh, and validation reliable over embeddings that would serve as the foundation for our chatbot's language understanding. Moving on to next slide. Yeah, so then we move with the using the of the word embeddings. So once our word embedding were trained, we moved on to using them effectively. We retrieved the vector for the word chatbot, which allowed us to see how the models interacts this concept. We then found words similar to chatbot, which the model identified based on their semantic similarity in the embedding space. Finally, we printed the results, which gave us insights into how well our embeddings captured the relationships between different words, improving the chatbot's ability to understand and respond contextually. And then moving with the methodology, where our model and initialization compilation worked. Well, with our word embeddings in place, we proceeded to initialize and compile our model. We started by importing the necessary TensorFlow and Transformers libraries, which are essential for working with BERT. Next, we initialized the BERT tokenizer and model, setting the stage for text processing and model training. Lastly, we compiled the model by defining the optimizer, loss function, and metrics, preparing it for the training phase. This step ensured that our model was ready to learn effectively from the data, ultimately enabling it to generate meaningful and context-aware responses. Mo- Passing to the Sreyash.
Yeah, hi everybody. So in this slide, we will discuss how we prepare our model for training. First step to involve the importing the necessary libraries, particularly TensorFlow and Transformers, which are crucial for working with BERT. Once the library were in place, we initialize the BERT tokenizer and the model. The word tokenizer converts text into the tokens, and the BERT model can understand the model uh, itself is initialized with the pre-trained weights, which provides a strong state point. for the chatbot. After initializing the model, we compile it by setting the optimizer, loss function, and the metrics. This compilation step is crucial as it defines how the model will learn and improve during the training. So now, training and saving the model. Once the model was compiled, we move on to the training, and it use TensorFlow fit method. Uh, we train the model in our suffered and the batch dataset. The training process was set to two epochs. One with the validation data being used to monitor the model's performance and avoid overfitting. After training and saving the data, we save the trained model and uh, save underscore pre-trained method, storing the specific directory path. This allows us to easy the load the model after deployment or further fine tuning, ensuring the work we have done is preserved and ready to use in real time application. These are the training and training accuracy and training loss chart. As you can see, we got the accuracy about 80 to 85%, and the training loss is very low. So moving to the conclusion, here, to wrap up the project, successfully develop an intelligent chatbot using the BERT and TensorFlow, achieving significant improvements in context awareness and overall user interaction. The chatbot's ability to understand and respond more human-like manner was greatly enhanced thanks to our careful data processing and model training and the use word embedding. Looking ahead, there are still opportunities for the further improvements such as fine-tuning and models hyperparameter and expanding the dataset to cover wide range of topics. These steps would help to refine the chatbot even more, making it even more powerful tool for the real world application. So thank you.